Okay, now we're looking at lab number 2, Chemistry for Biology and Introduction to pH. So when you print off or pull up your instructions, you're going to see the introduction will discuss pH with you. Now, if you are watching those videos that I've added to Canvas, that are those, I've called them the helpful videos, they're select topics that I lecture over from each chapter. If you've looked at chapter number 2, I discuss pH with you in that chapter. But let me go ahead and review the pH scale with you really quickly before we go on into what we need for our lab. So here is our general pH scale. Now, pH indicates percent hydrogen. So what we're looking at here is we are looking at the percent of the hydrogen ion concentration in a solution. That is what pH is. pH is a measure of the hydrogen ion concentration of a solution. And the pH scale, as you can see here, goes from 0 to 14, stopping at 7 in the middle. So a pH of 7 is a neutral pH. If the pH is neutral, that means that the hydrogen ion concentration is equal to this guy. This is the hydroxide ion concentration. And if those two things are equal, meaning we don't have an abundance of either one, then you have a neutral pH, what essentially distilled water is an example of a solution that has a pH of 7. So reading the scale, any number lower than 7 is considered an acidic pH. So as we go from 7 to 6, 6 is more acidic than 7, of course. The 5 is more acidic than 6. And 4 is more acidic than 5, and so forth. So a 1 or a 2, those are very acidic solutions. So the lower the number, the greater the acidity, or more importantly, the higher the hydrogen ion concentration of that solution. So that's why underneath here I wrote, okay, it's acidic as we go down towards 0, but I've also drawn an up arrow that indicates increasing hydrogen ions. So the lower the number of the pH, the greater the hydrogen ion concentration. Okay, so for example, a strong acid would have a pH of between 1 or 2, whereas a weak acid would have a pH between like 5 and 6. So then on the other side of the scale, you have increasing numbers, and we go from 8 to 9, etc., up to 14. And so there are two ways that you can look at that. We would refer to those as basic pHs, or becoming more basic as the number increases. And the other way to look at that is as the number increases, we are becoming more basic, which means we are increasing the number of hydroxide ions in the solution, or decreasing the number of hydrogen ions. So if you have a basic solution, you have a very low hydrogen ion concentration, but you have a high hydroxide ion concentration. So a strong base would have a pH of between 13 and 14, and a weak base would have a pH of between 8 and 9. So what you're going to be doing is you're going to be testing the pHs of household items, and there are some suggestions made within the lab of solutions you can use to test the pH for. But let's look at the equipment you're going to use. So again, you're going to wear your safety goggles, right? And you have your 400 ml beaker that you're going to measure 100 mils of water, no, 200 I believe. Let me check that before I commit to that number. On page 2 of the lab is where the protocol begins, and it does tell you, okay, to mix up, at number 1 at the top of the page where it says to prepare the cabbage juice indicator, you're going to add 200 mils of tap water to this. So fill it up to 200 mils. You are then going to add the cabbage juice indicator powder from the 15 ml conical tube. So that is this. So it's this purple powder. This was in the little kit bag numbered kit 2. This is the cabbage juice indicator, and you will add that to the 200 mils of water, and you will stir it up to make a solution. And this is going to be a pH indicator for us in this lab. Okay, then what you're going to do is you're going to select household chemicals to test for pH. And there are, you're going to use 4 of these plastic cups that were in your lab kit bag, the large one. You're going to use 4 of them. You're going to use your, it's referred to as a vis-a-vis marker. It's the black marker that is in your, there we go, that was in your bag, and you're going to label, and that way you can, rather than using a permanent marker, because you can then clean this off because you are going to reuse these cups. So, but you'll label it with whatever solution you're testing, okay, on the cup. The suggested solutions are maybe to test lime or lemon juice, or some kind of clear soda like maybe Sprite or club soda, baking soda, Alka-Seltzer vinegar, bottled water, liquid dishwashing soap, yogurt, apple juice. So there's a bulleted list on page 2 of suggestions. But then what's important about this as well is that it also tells you, depending on what you're using, how many mils of that material you want to use. And if you're using, for example, lime or lemon juice, to take 2 tablespoons of it and add it to 100 mils. So you may be actually making a solution with these as well. So be sure and read those instructions. Okay, once you have decided what you're going to test and you have prepared them in your cups and you've labeled your cups, you are then going to predict before you test them whether or not you think that solution will be acidic, neutral, or basic. And you're going to record that down. And you can record that in table 1, which is on page 3. So top of page 3, table 1, you see you're going to list your common household substances here, and then you're going to add your prediction in the second column. It will say predict whether or not it's acidic or basic or neutral, and you put your prediction. Then you're going to test it 2 ways. You're going to test it using the cabbage juice extract, the powder that you mixed up with the water. That is the first, or it's the third column, but that's the first test you're going to do. And then you're going to use these pH strips that you have as well in your kit, and you're going to use those and determine what the pH is according to those. So the cabbage extract, in that same kit, you're going to see this, and this is the key. When this solution that you mixed up in your beaker, when it comes in contact with various solutions, it will change colors. And so it might become a nice blue color, or it might become purple, or it might become pink, in which case, whatever color it becomes as a result of the pH of the solution, you're going to record the number underneath that color square. So if you add the cabbage juice indicator to a solution and it turns this kind of turquoise blue right above my finger, look below that, that's a pH of 9. So you will then record a pH of 9 in the third column. So you'll use the cabbage indicator first using this key. Then you'll go back and you'll use the pH test strips. So the pH test strips, I still have mine in my little kit 2 bag. These are the pH test strips. And you will dip those into each solution and compare them with this chart. So here's the chart that you have. And depending on what color the test strip becomes, that's the pH of the solution. And this is going to be a little bit more sensitive to pH, so this is going to be a bit more accurate than the cabbage extract was, but you're going to see how close you get with those, so that's kind of fun to watch. Okay, but then what you want to remember, this is really important, you have to include a picture of these results with your lab. So don't throw anything out until you've taken a picture, and you want to line your solutions up, put the test strips in front of them. You want to have the labels clearly shown so we know what solution was in each cup. And you need to have a signed piece of paper. So you have a piece of paper sitting in front of them with your name signed on them, indicating that that was your experiment and those were your results. You'll snap a picture, and then you'll upload that picture within Canvas, within the actual assignment submission page. I do want to mention one more thing. When you add the cabbage indicator solution to your test solutions, it indicates to use a pipette. When you read your instructions, this is a pipette, and it tells you to add 5 mils of the solution. Well, this all the way up to the line right below the bulb is the 1 mil mark. So you will need to, aspirate or draw up that cabbage juice indicator solution that you created 5 times, right? So that you're squirting 5 of these into each cup, into each solution, so you get an accurate reading. All right, and then you'll just, of course, again, answer the questions. Now, there are several items from this lab that you want to save. So if you'll be sure and read on page 2 at the very bottom where it says clean up, the instructions will tell you which items you need to save for future labs and which things you can get rid of. Okay, it's a great lab. It's really fun. I hope you enjoy it. Let me know if you have any questions.